Hi, Chris Kuzmal here. We're continuing our exploration of Python and numbers. And I have some code here which it does more than I would really like to have it do at this point in our learning. But there's some really cool things going on with Python that I want to share with you. Uh, and so in the left-hand side here, we have 8 lines of code. And some of it does maybe let's just we'll talk through it. Don't worry about it if you don't fully get everything that's going on or why, but you should understand. I still think you should be able to understand what this code is doing, maybe not why, how you generalize it. On line 1, we set a variable called particle count to the value of 1. And on line 2, we set another variable called count to 0. And I just chose those 2 variable names. And I'm going to do a loop, and we haven't talked about loops before, but basically line 3 says, whatever's after this colon and is indented, which is everything. All these lines of code are indented, and they're after that colon. So everything after this colon is going to be repeated as long as this here thing, this highlighted thing, is true. So as long as the count is less than 10, we're going to do all these things. And these 2 lines of code simply add onto whatever the variable is. So a line 5 adds 1 to count, and line 4 looks like it adds 1 to particle count, but if you look carefully, you see it adds 0.1 to particle count. And that's sort of interesting because, as you will recall, we learned in a previous video that 0.1 plus 0.1 plus 0.1 is not precisely 0.3. And so what we want to do is we want to repeat this, and we're going to actually repeat this 10 times. And that's what this while does. It repeats it 10 times. And then actually this line 6 and 7 we don't need anymore, but I think it might be kind of cool for you to have just seen that for a moment. It's like, what was that? What was that? Kuzmal. Don't worry about it. And then all we're going to do on line 6 is print the particle count. Okay. And so what do we expect to have happen? Particle count is going to start off as 1, and we're going to add 0.1 to it. What could be simpler? And here we run the code, and we see we get 1.1, which is adding 0.1 to 1, no problem. Then we get 1.200000002. And like, what? That's not exactly the same. But then we remember, oh yes, the computer, the bits, the binary decimal representation of a number is not going to be precisely able to capture every possible number. In particular, the binary floating point number can't represent 0.1 precisely, even though it presents the illusion that 1.1 is here. But we see very quickly that we're off by a very small amount. Okay, no problem. So what? But then I was thinking, well, okay, what if I were to do this many, many times? I want to see how rapidly the error accumulates. And so one thing I can do is I can increase the count to 100. I can increase the count to 1,000. And I can see that as I increase the count, the amount that I'm off begins to accumulate. My error accumulates as I keep incrementing. But another thing that I noticed was that if I count really high, it seems like, and this is just, if you look at this, you may not be able to tell, but it seems like the error is getting bigger faster as the size of the number we're adding up increases. The amount that we're off gets bigger. That doesn't just accumulate; it accumulates and accelerates the accumulation. It seems to. It's an observation I make that maybe you can't spot when you watch this, and maybe it isn't even happening. Maybe it's an illusion. So let's do a little science, as it were. I'm going to take this count back down to 10 only, but I'm going to start at a different level. Rather than starting at 1, I'm going to start at 10,000. Okay. And now when I run, I see, well, I don't know, is the error off by more? Not so clear. So next video, we'll scale up and see.